In far northwestern Pakistan lies an incredibly hot and arid desert rich in sand dunes. Here, there is very little vegetation owing to the fact that it can at times go several years without any rain falling. Adding to this is the fact that across 5 months, daily high temperatures in this province of Balochistan regularly exceed 40 degrees Celsius or 104 degrees Fahrenheit. Thus, you might think that this setting would be an unlikely location for volcanoes to be situated, especially due to its distance of 440 kilometers or 273 miles from the nearest ocean. In fact, Pakistan is the single largest country on the planet in terms of overall population to not have a single active volcano, unlike, say, India, which has either 1 or 2 active volcanoes depending on the source cited. Yet, despite not having any active volcanoes, this absence does not mean that Pakistan doesn't have a small risk of producing another volcanic eruption in the future, as in the remote desert region that I just described is a large yet highly eroded volcano which even today allegedly still contains active fumaroles indicating likely magma at depth along with a series of hot springs. This is the story of Pakistan's debatably dormant rather than extinct volcano which has a very low albeit possible future chance of erupting again one day. The volcano in question is known as Koh-i-Sultan, which last produced an eruption 90,000 years ago, depositing large volumes of pumice over its southwestern slopes. While much about this volcano is still unclear, I interpret that this most recent eruption occurred within the eastern portion of its Marico cone, forming a 940-meter or 3,084-foot wide Mar crater in the ground inside a pre-existing lava dome. I personally interpret that this eruption reached a volcanic explosivity index of a 4, ejecting 0.18 cubic kilometers of tephra. Now, for a brief overview of this massive 1,428 square kilometer volcano. The Koh-i-Sultan volcano consists of 4 large volcanic cones which each, while highly eroded, contain a prominent caldera on their summit, owing to ancient, incredibly powerful explosive volcanic eruptions. It thus should come as no surprise that a whopping 90% of this complex is not composed of lava, but instead a combination of ash, pumice, and pyroclastic flow deposits from various explosive eruptions. The thickest of these deposits today has a stark white color representing pumice-rich ancient lahar deposits that descended this volcano's major drainages. Of the remaining 10% of rock which does represent lava, it consists almost entirely of andesite, with incidental amounts of basaltic andesite and towering lava plugs representing eroded magmatic intrusions that form monoliths out of dacite rock. Depending on the source cited, all 4 of these volcanic cones formed since either 5.9 million or 2.4 million years ago, although I will go with the earlier figure. So, why does Pakistan have a sole dormant volcano so far inland? The answer is a major tectonic plate collision in the Arabian Sea. There, the Arabian tectonic plate is subducting underneath the Eurasian plate, albeit at an incredibly shallow angle. This near-flat subduction eventually caused partial melting to occur on the subducting slab far inland, causing batches of magma to occasionally intrude into the crust, sometimes erupting onto the surface and forming a chain of volcanoes. This chain of little-known volcanoes is referred to as the Makran-CHAGAI magmatic arc, including dormant volcanoes such as Taftan and Basman in Iran and Sultan in Pakistan. The exact age progression of eruptions at Sultan's 4 main cones are unclear, but allegedly there were 5 distinct eruptive periods associated with the construction of a distinct peak, followed by long periods of inactivity, possibly spanning hundreds of thousands of years each. Based on the level of erosion present, I would estimate that this is the order the peaks formed in from oldest to youngest. The vast yellow-tinted area surrounding its youngest peak marks an extensive hydrothermally altered region, even containing a native silver deposit from which more than 10,000 metric tons of material was mined during the 20th century. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.